The bell for more thought-provoking content. We live in one of 8 confirmed planets in the solar system. We orbit one star of around 100 billion stars in the Milky Way galaxy. At the lower estimate, the Milky Way galaxy is just one average-sized galaxy among approximately 200 billion galaxies in the universe as a whole, according to NASA figures. The universe is 13.8 billion years old, and the observable part of it is 93 billion light-years old. The unobservable universe is potentially infinite in nature. The entire thing is expanding at an accelerating rate, as well devouring the seeming nothingness beyond. And yet, it can, and probably will, die. The ultimate fate of the universe is a question that humankind has wrestled with for centuries, but never more so than in the last few decades. The list of potential scenarios is by now well known. It could be that our expanding universe hits reverse and everything ends in a big crunch. It could be that expansion continues until it can continue no more in the big rip, or that the total energy within the universe eventually fritters away completely in a big freeze. With all those possibilities though, it's not as though we're ever here today, gone tomorrow. If humans were around at the end of all things, which is laughably unlikely, but still, then it will be a very gradual grinding to a halt over billions or even trillions of years. There are some scenarios where this wouldn't be the case, such as should this universe actually be just the plaything of a higher power who then just decides to switch it off. That would be instant. But it's also not an end of the universe theory that ranks especially highly at present in terms of what's most likely. Current science predicts a long and slow death, no matter which route the universe ends up taking. For today's video though, we're imagining that the big crunch isn't what will happen. Instead, we're in a reality where we're headed either for the big rip or freeze. The universe doesn't rebound or retract. It just continues expanding, and the mechanics of it carry on mostly unchanged. To understand what will happen next in general, we can first look at our own sun. The sun has been happily burning for around 4.6 billion years now, and very early in its life, the rest of the solar system formed around it. The inner, rocky planets, the outer, gaseous planets, the countless asteroids, and endless cosmic dust. We know that the sun in its current form has likely already passed the midway point in its life. In about 4 billion years' time, it's expected to go red giant, to rush outwards as part of a ruthless, fiery explosion that will totally reshape its surrounding area, including the Earth, which might even find itself devoured completely. But while the transition to the red giant stage will be a momentous time for the sun, its story doesn't finish there. It's sometimes shown as though the red giant will be some kind of final explosion for our star. But really, it's the sun reinventing itself. In turning into a red giant, the sun's fusion of hydrogen into helium stops. For a while, it will fuse helium into carbon instead, as it enters into a whole new era. Around half of the sun's mass will then be lost, blasted out into space, but the other half will remain as a white dwarf, a scorching ball of spectacular density, about the same size as Earth is now, or slightly larger. From here, it's a long time until the sun's next major change. In its white dwarf form, it'll simply be cooling down. But such is the immense energy contained within it, that cooling down process will take literally a quadrillion years at least. Many, many times longer than the total age of the universe so far. When it has cooled to almost absolute zero though, it will no longer be emitting visible light. It'll no longer be producing anything much in terms of energy. and will be left as an impeccably dark mass suspended in space. Now, our sun, the star that once provided all we need to live, has truly reached the end of its timeline and has become a black dwarf. At present, a black dwarf is a hypothetical star type, seeing as there hasn't yet been enough time in the universe for any of them to form. However, scientists do believe that this is the ultimate fate for many low-mass stars, like our Sun. For more massive stars, there are other endgames available, including collapsing into a black hole or a neutron star. But for smaller stellar masses, those fates aren't possible. When they reach black dwarf, they're classified as remnants of what they once were. The power within them has petered out, although they might well still exist until the end of the universe itself, via the Big Rip or the Big Freeze. So, what would happen if we lived in a black dwarf universe? Essentially, nothing much. Imagine that you had a working time machine, shooting as far forward in time as it's possible to go. Trillions upon trillions of years later than now, you could well arrive at a moment when black dwarves and black holes are all there is. Only, thanks to expansion, none of these essentially invisible objects are even close together anymore. Millions of light years separate one stellar husk from the next. The planets that once swirled around them are long gone. The chemical makeup of the universe has broken down, and the prospects for life are almost certainly zero. More than any other doomsday scenario, this really is the end of all things. That is, unless life has found a way. Again, what we're picturing here is a time so far removed from right now that really it's impossible to comprehend. Modern humans are only a few 100,000 years old and have only been around for a tiny fraction of the Earth's and the Sun's total lifetime. Meanwhile, the Earth and the Sun have only been here for around a third of the time that the universe itself has. But even all of that, everything that has happened so far, fades into minuscule insignificance compared to anything that makes it to the black dwarf age. If life has survived, and that's probably one of the biggest ifs we've ever contemplated on this channel, then it must surely mean one of two things. Either life has transcended to a wholly non-physical form and no longer relies upon the universe to host it, or life has cracked open the multiverse and so can view this universe's fate as if from another dimension. What's your verdict? Could life survive to see space as we know it, marked only by cold and drained black dwarfs? Or is this a jump into the future that nothing else can take? It's certainly one of the bleaker possibilities for how all of this could end. The sun as we know it, as we've always known it, seems as though it should be eternal, an unbeatable, undiminishing power source. But the sad truth is that it isn't, and that even it will one day fade out forever. Between now and then, and a seemingly much more pressing concern for Earth at least, is the red giant that the sun will balloon into in about 4 billion years' time. For life on Earth, this means that our planet will actually become too hot to live on in only around 1 billion years' time. Our days are already numbered. Our planet is already locked in a huge challenge that lies ahead. But while it can feel as though the coming red giant should really be all there is to worry about, there's sure to arrive a day when even that's long forgotten. As we are, it can be easy to forget just how fleeting our own existences will ultimately prove to be, not only individually, nor even as a species.